In this video, we're going to introduce the idea of comparing different fractions. This image that I have here is of fraction strips. If we were in class, we would have made this together. I like the kids to really understand this idea that if this is how big the whole is, this is what 1/2 looks like, or if the whole is split into 2. If we'd been in class, I would have had you write on your paper, for example, that up to here is 1/2. This is over here is essentially 0. And this is kind of like 2/2. The idea of that being you can really see vertically sort of how they compare. So I'm going to write a couple in, but then you'll just get the idea. So if this is 0, 1/3 is at that line, 2/3 is at this line, 3/3 is at that line, or the whole. Same, 0, 1/4, 2/4 would end here, 3/4 would be here, and 4/4 or the whole would be there, etc. Okay, just keep that in the back of your mind. Because a lot of the earlier sort of practice activities you're going to do really come with pictures, that visual element, you don't need to look at this fraction strip image so much, but it's good to remember we have it here. To have that in your back pocket, you can easily find one on the internet. I just Googled fraction strip image, or obviously you could use the one from this video if you want to pause it. So our first example, which fraction is less, 1/2 or 1/8? Not supposed to be a trick question, very simple. Obviously, 1/8 is smaller. The thing to keep in mind here is kids will sometimes think, oh, 8 is a bigger number, so 1/8 must be bigger. That is not the case. The higher the denominator, so the bigger the number of pieces it's split into, the smaller those pieces get. Imagine a pizza. I'm going to give you 2 pizzas. I've ordered 2. I've split one into halves. So I'll say I'll give you either 1/2 of my pizza, and I've split the other one into 100 pieces. Sorry, it's very hard for me to draw that, but you get the idea. Kids might say, oh, I want 1/100th of a pizza because the 100 means it must be really big. No, if I split a pizza into 100 pieces, the 1/100th of a pizza would probably be as big as that green. Whereas if I split a pizza into 2 pieces, 1/2 of the pizza is way bigger. Wrapping your brain around this concept can be tricky. That's why I'm starting with the visual. Obviously, 1/8 of the box is less, so we're going to circle that one. Another way to look at fractions is using number lines. This looks quite similar to our fraction strips down here. Again, very straightforward. Which fraction is bigger or greater? 4/11 or 9/11. With the visual, it is very obvious that 9/11 is closer to 1 whole. You'd rather have 9/11 of the pizza than 4/11. If I split the pizza into 11 pieces, assuming you're very hungry, you'd rather have 9/11 than 4/11. So 9/11 is bigger. One of the practice activities you'll do is comparing fractions where either the denominator is the same or the numerator is the same. If you're comparing 2 fractions and you have one of those similarities, it makes it a lot easier. I find the easiest is if the denominator is the same, because that's when we've cut the pizza into the same size pieces. So it's easy to say that 2/6 of a pizza or 2/6 of this rectangle is bigger than 1/6 of the pizza or 1/6 of this rectangle. It's a little, Miss Cooper didn't read that direction correctly. It says which fraction is less. So sorry, 2/6 is bigger, which is less. 1/6 is the smaller fraction. So comparing when the numerator is the same is, I'd say, slightly more challenging, but still easier than when you don't have any similarities. You just have to think kind of like about this example we had down here with our pizza. Would you rather have 1/2 a pizza, or would you rather have 1/100th of a pizza? The biggest mistake kids made, as I said before, is they immediately think the 100 is the bigger one. Actually, if your numerators are the same, the one with the smaller denominator is going to be the bigger piece. If we look up here, we see we have 2/3, which is a large portion of this square. And then we have 2/8, which is much smaller. So this idea of flipping our thinking, the bigger the denominator, the smaller the amount of the whole that's filled in when the numerators are the same. 2 parts of a whole that's split into 3 is much bigger than 2 parts of a whole that's split into 100. Just like down here, 1 part of a whole that's only split into a 2 is much bigger than 1 part of a whole that's split into 100 pieces. Always go back to this pizza example as sort of a concrete thing to remember. So which fraction is less? Obviously 2/8 is the smaller fraction. When we look at this comparison, which fraction is less, 9/10 or 3/10, we notice that our denominator is the same. So the pizzas have both been cut into 10 pieces. 9/10 is obviously bigger than 3/10. You could also look over here. Well, there's 3/10. 9/10 is way over here. So that's pretty straightforward. Which is less? 3/10. In this example, which fraction is greater, 4/8 or 4/6? Our numerators are the same. So we can think kind of that pizza example, okay? The one with the bigger denominator must be smaller because this shape's only split into 6 pieces. This one's split into 8 and we have 4. So I would say 4/6 is bigger. If you want to clarify it for yourself, what you could do is go, okay, there's 0, 1/6, 2/6, 3/6, 4/6. I'm just going to write a little mark there. That's 4/6. And then 4/8, I'm going to count over. So 0, 1, 2, 3, 4/8. 4/8. So if we compare where those are in terms of sort of a number line, 4/6 is obviously bigger than 4/8. 4/6 is greater. This is the first example we've come across where we don't have we're comparing the fractions, which fraction is greater, but we don't have a similar numerator or a similar denominator. This can be a bit tricky for kids. Because this example has a picture, it makes it a lot more visual. I want you to start to try and think about the questions though as well. Think about what 1/5 would look like, and that's very easy because there's a pie right here, okay? 1/5, I'm splitting my whole into 5 pieces, only one's colored in, versus if I had a whole and I split it into 10 and I colored 5 in. I'm hoping your brain will start to realize that, 5 out of 10, that's half of the whole shape. So I'm hoping you'll start to think, hey, 5/10, half the shape colored in is going to be bigger than 1/5 of the shape colored in. Right now, it's easy to tell. Yes, obviously this one is the greater fraction, more is colored in. So I'll circle that, 5/10. But when they take these pictures away, I'm hoping you'll start to be able to do that in your mind. Or you can always use one of these fraction strip sheets as well. In this final example, we really just need to use our understanding of improper fractions. Let's read the instructions. Graph 3/2 and 3/4 on the number line. Write an inequality comparing 3/2 and 3/4. So which is greater, which is less or equal, etc. So 3/4 is really easy for us to find because it's already written there. There's the 1 whole, there's 2 whole, there's 0, and there's 3/4, 1/4, 2/4, 3/4. So I'm just going to sort of circle that one for us in red. What's a little bit different is now we want to think about halves. This isn't written in halves, it's written in quarters. I think this might be obvious for some of you, but just to make it really visual, I want you to see that 1/2, and this is where that fraction strip sheet is handy, is equal to 2/4. I think you're not that surprised if I split a circle into quarters, color in 2 of them. 2/4 is the same as saying 1/2 the circle. So on our number line here, we have 0, we have 1. In the middle, we have 2/4. We can also say 2/4 is equal to or the same as 1/2. Again, looking on our fraction sheet, shouldn't surprise you too much. 1/2 is equal to 2/4, because 2 is half of 4, is equal to 3/6, 3 is half of 6, is equal to 4/8, 4 is half of 8, equal to 5/10, 5 is half of 10, and equal to 6/12. 6 is half of 12. Getting familiar with equality or equalness between different looking fractions is a big part of understanding fractions. Just because the numbers are different, 2/4 and 1/2, doesn't change how much of our whole is colored in. Continuing with this question specifically though, so we have 1/2 there, and then I think you understand that 1 whole is the same as saying, okay, 2/2 or 2 of the parts are colored in. I have a shape split into 2. If I color both pieces in, 2/2. It is also can be written as 1 whole. Think back to your mixed fractions. And then here, we have 2, so that would be 2 whole. 2 whole would be 4 pieces colored in over 2. So in the middle here, where it says 3/4, where it's just adding another half before we get to 2 whole, it would be 3/2. So 0 to half, 2/2, 3/2, 4/2. So now this question becomes really simple. Write an equality, which is bigger, 3/2, which is here, or 3/4, which is back here. Obviously 3/2 is bigger. 3/2 is greater than 3/4. Hey, Miss Cooper, they have the same numerator. Couldn't you have just said, hey, this one has the bigger denominator, so obviously that's going to be the smaller one? I'm just seeing that now, but I've had a chance to teach you another way of looking at it. So good luck with the activities.